Hey everyone, as you can see, I've made some progress on the shop. I've built out the base cabinets, I've added the Sys Gen 3 rails and Sys AZ drawers. Next step in the process is I want to show you how to build some doors and drawers for these base cabinets. So let's get to work. So as I like to always do, I went ahead and I drew out how I wanted to lay out my shop. I designed it for Sys Gen 3 rails as well as Sys AZ drawers. And up top here, I'm going to go ahead and build out 3 drawers to hold miscellaneous pieces. Center section over here will be all drawers. I've built one out so you can see what it's going to look like. This will be for holding larger accessories, any large pieces that won't fit in a sustainer. I haven't completely decided what I'm going to put in these areas. I'm going to go ahead and build some doors for them. 2 here and 1 across here. To complete this build, I'll be using the TSC 55K and the K-PEX to break down some of the sheet goods. Then I'll be using the domino to do some of the joining. I'll use the OF 1400 and the MFK 700 on the drawers for the dados and some of the roundovers. Then I'll be using the DTS and the ETS EC 125 to do some of the finish sanding. Then I'll be using the TID and the CXS to install some of the hardware. Then I'll also be using the VAXIS for clamping. There's a lot of different ways to assemble a drawer with different joinery types, like this many. I've chosen 2. The first one is the quickest in my opinion. It's the Domino DF 500. The second way is using a locking rabbet joint by utilizing the MFT and the OF 1400 router. For the bottom of the drawer, I've decided to run a dado on all 4 sides. This encapsulates the plywood, makes for a stronger box construction. For the material on these drawers, I've gone pretty basic. Just got 3/4 inch birch plywood and then 1/2 inch pine plywood. The 3/4 inch is going to be the sides, the front, and then also the drawer front. And the 1/2 inch I'll use for the drawer bottom. Gone ahead and I've ripped down all the 3/4 inch plywood for the sides, fronts, and backs. I'll wait to cut the plywood for the bottom until I get the drawer box in the dry fit stage. You may remember in previous build series, I had a set of digital plans you could follow along with me during the build. The doors and drawers are very specific and unique to my setup. They may not fit what you're planning on building. If you'd like a basic outline, check out the link in the description below. Before we get started on cutting everything to size, let's talk about proper drawer box construction. You always want to make sure that you've got the front and the back of your drawer box in between your 2 sides. That way, if you're using a domino tenon, for example, I've got my domino going in through the side piece and through the front. Now when I pull on my drawer, I'm pulling on all 4 pieces. If I switch it around, now if I put a domino tenon in there or even a screw, as I pull on that drawer over time, that could loosen up and just pull the whole drawer front off. As I mentioned before, I've already gone ahead and ripped down this material to the correct width with the TSC 55K and a set of parallel guides. If you want to know more about how to use those, check out the link in the description. Before I cut all the pieces to size, I want to talk to you about the K-PEX setup. I want to design as much flexibility into it as possible. So I designed this whole row of cabinets so that it would fit in there perfectly with 8 feet on either side of the K-PEX, so that the K-PEX would be the same exact height as the MFT and the cabinets beside it. I also designed it so that I could utilize the UG brackets so that I can take this off, put it on the UG cart, and then when I'm done, bring it back and it falls right back into the same place. I chose the CT15 to use with the K-PEX because of its compact size and its simplified design. As with most projects I do, I like to maximize material for waste. For the drawers in this one, I know I can get 2 long pieces and 1 short out of 1 8-foot board. So let's go ahead and square this one up. For ease of use and repeatability, I went ahead and cut in a spot for a T-track, added an imperial and metric tape measure, and made my own flag stop. So now I'm ready to make the first of 2 850mm cuts. Since I've already got my flag stop set for that 850, I'll go ahead and set this aside and finish cutting all those. With the cutoffs from these pieces, I can cut my sides. So those are all going to be 355 millimeters. So I've got this board clamped down to be cut at 355 millimeters. I have a flag stop, but my tape stops at 370 millimeters. I made this stop wide enough so that I can slide it all the way down and it still grabs the T-track, locks it into place, and I can cut all my boards at 355 millimeters without having to pull out a tape measure. With all these pieces cut, the next step is to cut the dado to accept the bottom panel of the drawers. I'll be using the 1400 router, the edge guide, and the Vaxis. The bit I'm going to be using is a 1/2 inch downcut spiral bit for all the dados in the large drawers. The perfectly straight edge that I accomplished with the TSC 55 and the parallel guides will give me a good straight edge to reference my edge guide off of, which will in turn give me a perfectly straight dado. Before we install the edge guide on the 1400, I want to go ahead and switch out the bit to that 1/2 inch bit. This is one of my favorite features on the OF 1400 is the collet change. You only need one wrench. We have a ratcheting collet. So to take the collet out, I just press on the down arrow. And there's a second stop in there. It's a safety stop. So once you break it loose that first time, you'll loosen that collet a couple turns and you'll feel it snug up again. That just keeps that collet from loosening up too much over time. Then I put the other bit in, get it finger snug, and then push the ratcheting collet with the up arrow. And I like having it in this position, so when I go to tighten it, I can actually use the leverage of the handle and just snug it up. Don't over tighten the collet. If you over tighten the collet, the next time you have to tighten that collet, you're gonna have to tighten it even more and more and more, and over time you won't be able to tighten it enough. So just snug it up and then you're good to go. Now I can attach the edge guide. First thing I'll need are the guide rods. These guide rods come with the OF 1400 router. If you don't think you have them, look again. They're the same color as the liner and the sustainer. Sometimes they blend in. First, I just slide them into the grooves here. I usually like to offset them because it's easier to get the edge guide on at that point. And then just tighten down this one cam lock, and that locks both the rods. Now I can attach the edge guide to the guide rods. Just slide it on like that. And I'll just get it close for now, tighten down the thumb screws, and then once I get my material clamped down, I can fine tune that adjustment. The last adjustment I'm gonna do to the edge guide is actually close off these two guide strips. What these are for is if I'm using a edge forming bit that doesn't have a bearing, I can open these up so they're not cutting into the bit itself. But since I'm gonna be in on the material, I can close these up and get a lot more surface area touching the edge guide. Now I've got one long solid strip torn up against my plywood. So now I'm pretty well set up for that dado. You can see I've got a nice long guide strip to reference off my material. But if I was gonna do a rabbet, and that bit would be hitting that plastic and I wouldn't be able to get my full rabbet. So I can open up those two pieces of plastic, slide the edge guide over just a little bit more, and I still have good reference area off the edge of my material. So when I built this MFT3 rolling cart in the previous build series, I built this little notch so that when I use the Vaxis on any of my material, it can reference off of here. So for longer pieces, I've got support here while the Vaxis clamps it down in place. So for laying out this dado, I like to keep it simple. I'll use the metric system. I know that I'm using a 12 millimeter bit, which is about 1/2 inch. And I want the bottom of that dado to be 12 millimeters up from the bottom of my drawer. So if I want to find the center of that dado, I know it's 12 millimeters plus half of 12, which is 6, equals 18 millimeters. I can draw that center line in 18 millimeters, line that center line up with the center line on the router, and know that it'll be exactly 12 millimeters from the bottom of my drawer. Now with everything laid out on my board, I can do my course adjustments just by kind of eyeballing it, getting it close, and I'll tighten up these thumb screws. Now to micro adjust it, I loosen this large knob on top, and I can twist this green dial, which will get my center line lined up perfectly with the router. And then just tighten that down. Now we can set the depth. Depth is very easy to set up on any of the Festool routers. first thing I want to do is just bottom it out so that bit is actually touching the material. Twist the locking knob, and then I want to loosen all these up, push them down so they're touching one of the posts on the turret, zero everything out. Now I know that I want to go down 12 millimeters, which means I want to raise this up 12 millimeters. Now, the scale on this router is imperial, so I want to go metric, so I'll actually take two 6mm domino tenons, put those in between the shaft and the post. I know that's exactly 12 millimeters. I can lock that down. Now I can go down 12 millimeters into my plywood. So with everything set up, I can go ahead and knock out all the dados for the large drawers. So with all the short sides done, we can move over to the large sides. You may have noticed that not all the dust was captured on a couple of those, and that's because I started the dado from the very end and I ran it all the way out to the other end, basically creating a chute for that dust to run down. Also, the bit that I'm using is a downcut spiral bit to counteract the chip out. So the dust extraction plus the bit, we're fighting each other, but I'll show you on these other two where I'll plunge here, I'll run the dado all the way out, and then I'll come back and get that last little piece, and then I'll collect almost all the dust. So as you can see, by creating that dam, essentially, the dust didn't shoot out that way. It stayed in the dado, but now when I come back, it'll suck up all that dust, and I can finish off that last little piece. The process I follow when I'm building drawer boxes is I create the box first, then I'll double check the measurements for the drawer bottoms. I like to set it up kind of in a production style. I'll go through and I'll just draw roughly where all my tenons are going to go, because I'll have two in each joint. And then we'll talk about laying out the exact position of the tenons. So these are not exact, these are just for reference, so I have a visual cue as to where the mortises are going to go. So for the joinery of the drawer box, I'm going to be utilizing the support foot that comes with the domino. It has these extra stops that will create a 20mm offset from any edge I reference off of. That'll be great for the top, that'll come down 20mm, but if I did it on the bottom, 20mm would be dead center of my dado. I don't want to do that. So what I'll do is I just created a gauge block that if I reference off the bottom edge, I can put a pencil line, then I can use the cursor on the domino fence to line that up with a loose mortise. So now I'll go ahead and mark for my bottom mortise. If this is your first time watching the build series and you want to know more about this rolling MFT cart, check out the link in the description below. So the tenon I'll be using for these mortises is a 5mm by 30. So I've got a 5mm cutter installed in the domino. I'm going to set the fence to 90 degrees. And I'll set the height of the domino fence to 20mm, and the plunge depth will be set at 15. And then I'll bounce back and forth between a tight mortise setting and the second loose mortise setting. So the top mortise, being the tight mortise, will be my alignment mortise. Now I can flip it around and do the same on the other side. When using the narrower pod, make sure you don't put it over the dado, otherwise you won't have full suction. For the short sides, I'll be doing the mortises vertically. So with those 4 done, I can go ahead and knock out the rest of the large drawer box pieces with all the mortises. Now that I have all the mortises in the large drawer box pieces, we can go into a dry fit and then measure for the bottom panel. The dry fit process is fairly straightforward. I like to have my dominoes close by, a little hammer, and a piece of abrasive. Because I'll take my tenons and I'll just sand off the top little ledge on the edge there. So for dry fit purposes, they slide in a lot easier. With all the tenons in the end pieces, I can go ahead and start attaching the end pieces to the side pieces. Now I just need to measure for my bottom. I like doing it after everything's dry fit together. That way I have points to measure from. So once I measured my width and my depth, I went ahead and added the dimensions for my dado. Came up with 870 millimeters wide by 334 millimeters deep. Now, since I know everything was cut square, everything was cut the same dimension, I can cut the bottom panel for this and the same size for my other 3 drawers, and they'll all fit. Because I'll be cutting several pieces at the same exact width, I'll be using the parallel guides with the 3000 rail and our TSC 55K. If you have more questions about setting up the parallel guides, check out the link in the description. Now that I've got the parallel guide set to cut at 334 millimeters, I just need to rip 3 pieces exactly the same width, and then I'm ready to cut them to length. Now with them ripped to width, you can go ahead and reset and set up the crosscut station with the MFT3 to cut them to length. If you have any questions about setting up the cross-cutting station with the MFT3, check out the link in the description. So now I know I need to cut these to 870 millimeters long, but because I'm in a small shop, I don't want to be flipping the board back and forth trying to square up both ends. So what I'll do is go ahead and measure out 870. Now that I know that, I can slide this right where my saw is going to cut, but I'll make it about 1/4 inch longer. That way, once I cut this piece, then I can flip it over, cut it to exactly 870 millimeters, set my flag stop to that, then I know all the other pieces are going to be exactly that same length. So I can only get 2 drawer bottoms out of 1 8-foot sheet of plywood, so we'll have to do this one more time. Process that I usually use for gluing up my drawer boxes is I'll glue up the tenons for one end, attach the 2 sides to that, slide in my bottom, and put on the other end. So now I can repeat the process with the remaining 3 large drawer boxes. With the last one pulled out of clamps, the next step in the process is to ease over some of these edges, do a light sanding, and then we can move on to putting on the drawer slides. To round over that top inside edge of the drawer boxes, I'll be using the MFK 700 with a 1/4 inch round over bit. I'm just going to take off the sharp edge. You can set the round over to as deep or as shallow as you want. So while I've got the drawer here, I might as well go ahead and sand all the top edges, remove any pencil marks that might still be there. I'm going to be using the ETS EC 125 with a 120 grit paper. To get some of the inside corners, some of the pencil marks, and some of the glue residue that was left behind, I'll be using the DTS 400 with 120 grit paper. With those all routed and sanded, I can move on to the next 3 drawers, and then we can start putting on the drawer slides. Save a little bit of time. I didn't sand what was going to be behind the drawer front. It'll never get seen. With everything sanded and routed, the next step in the process is going to be installing the drawer slides. I want to do that before I put on the drawer fronts, then I can have the drawers in the carcass and align the drawer fronts to be exact. When I was designing this shop, I wanted to make sure I had a spot for everything, especially the cabinet hardware. So with this new Sys 3 rail system, I can use a large sustainer to keep all my cabinet hardware in. There's a lot of different ways to install drawer slides. I've come up with a system that works for me. I usually take apart the drawer slide, and I've laid it out so all I have to do is just space it off the bottom of the drawer by a 1/2 inch. So I've got a piece of 1/2 inch plywood here. Pre-drill the holes, install the screws, and then this part for the drawer is done. Then I can move on to the slides in the carcass. So I've got the T18, keyless chuck, and a self-centering bit to get those holes drilled. So now I'll use the CXS and I'll adjust the torque settings so I don't over torque the screws and attach the drawer slide. For installing the rest of the drawer hardware in the carcass, I just use an 18mm piece of plywood as my spacer off the bottom, and knowing that my cabinets are square and plumb, I can then figure out the distance in between, divide it by 5 spaces for 4 drawers, and I came up with that measurement. Now I just have to throw some screws in it and work my way up. With that side complete, I can do the other side, same spacer block, same spacing, everything will be the same. With all the drawers installed, I can focus on the drawer fronts, which I've already cut to size, rounded over the edges, and given a light sand. Whenever I'm installing drawer hardware, I make myself a gauge block. Drill 2 holes in it, got a center line on it. Those holes are spaced exactly the same distance apart as the drawer hardware. Then I can just put it on the center line of the drawer, drill my holes, and then I'll show you what I do with those holes when I'm installing the drawer fronts. With all the holes drilled for the drawer hardware, I can go ahead and get them installed. Cut some spacers that I'll rest on that first drawer that I have installed. Put a drawer front on top of that, line out the edges, drill my holes. Now I can take a screw, run a screw right in there. With those 2 screws holding the drawer front on, I can screw it in from the back and then put my hardware in. So now I've got the large drawers completed, all the hardware's on them. Now I can get ready to start working on the doors. Before I start the construction of the door, I need to add a face frame to the back side of this cabinet wall. My door is going to hinge from this side and close onto that side. So I'll go ahead, pre-drill some holes, and secure it with some screws. Once I get this added, I can grab some measurements. So with the opening prepped, I can go ahead and grab measurements for my door. I'll be using full overlay hinges. And based on the recommendations of the manufacturer, that determined the actual size of my door. Your hinges may vary, so just double check those recommendations. Today I'll be making a frame and panel door. That'll consist of 2 mitered rails, 2 mitered stiles, with a dado in the middle to accept the panel. First thing I'll do is cut the rails and stiles to rough length. There's several different ways you can do this dado. I just prefer the MFK 700 because of its size. It's easier to balance on these smaller pieces. And with my setup, once I get one dado done, all I have to do is just readjust, move this piece back, lock those in place, do the next one, and keep repeating that process. I'm only adjusting the machine once, moving the material for the machine. Similar to what I did with the 1400 router, I can adjust the base and the edge guide of this router to my center line that's marked on the base just by loosening these screws and adjusting the micro adjust to get that perfectly centered. Lock these back down. Once the base is back installed on the router, I can set the depth. Just loosen the large knob here, and then this green knob is my micro adjust. I'll be making this dado 9 millimeters deep. So I'll just use the spacers that I already have, which is a 5 millimeter and a 4 millimeter domino tenon, and just line it up that way. Now I know that's exactly 9 millimeters, and I'm ready to cut. So with the dados cut, now I can take them back to the K-Pex and cut them to final length. I'll be cutting the stiles first at 755 millimeters, long point to long point of a 45-degree miter. Got them clamped in place using a stop, so that way each piece will be exactly the same. And I'll also follow the same process for the rails. With the dados complete, now I can work on the joinery. I'm going to be using the domino with a 4 millimeter cutter, so we'll be using a 4 by 20 millimeter tenon. For the layout, it's pretty straightforward. We're going to be using the support base again, so I'll be using the 20 millimeter offset off the long point, and then coming in off the sharp point, I'll just be referencing off of this edge and making a loose tenon at 25 millimeters. For the plate height, I'm going to set the gauge block at 20 millimeters, which will make that mortise 10 millimeters down from the top surface. The depth that I'm going to be plunging to is 20 millimeters. With all my settings correct, I can make my first mortise. With all the mortises cut, now I can do a dry fit. Once I do the dry fit, I can measure from my panel, just like I did with the drawers. Dry fit's complete and it looks good, so the next step in the process is to measure the height and the width of the inside of the door frame, and then add 14 millimeters for that panel. That accounts for the 9 millimeter depth dado on the top and bottom and both sides, plus a little bit of wiggle room for expansion and contraction. So now I'll do a quick dry fit of everything, make sure everything fits good, and then we can move on to glue up. With it all dried up and pulled out of clamps, I can go ahead and give it a light sanding, and then we'll be ready for hardware. I'm going to be using 35 millimeter cup hinges. There's a lot of different styles out there, a lot of different manufacturers. So please read your instructions once you get your hardware and base your installation off of those instructions. As I was finishing up that small door, I really started to look at the area that I had planned for 2 doors and what I would plan to store in there. And I thought about the nook that I put over here. So I decided to put a nook over there as well to store small pieces of material, things of that nature. And then basically making that 2-door area into one giant door. The process for this large door will be the same as the small door. We'll have rails, stiles, and a center panel. So now with both of the doors completed and a bonus extra cubby, the next step in the process is to finish up the small drawers, which will be done almost like the big drawers with some slightly different joinery. I wanted to show a different option for creating a joint for the drawer box by utilizing the Festool system. So as you can see here, this is a finished small drawer with the lock rabbet joinery. The way it works is the front part of your drawer has a rabbet joint on it. The side part has a dado that matches that rabbet. So when they lock together, as I pull on the front of the drawer, it pulls the side with it, similar to the domino joint. To create the locking rabbet joint, I'm going to start with the vertical dado that will accept the front rabbet. To do that, I'm going to be using the MFT3 with the cross-cutting station, the OF 1400 router, and the guide stops, and a piece of plywood that I laid out some predetermined marks on to create this locking rabbet joint. I went ahead and broke down all the material and ran the dado in the bottom of all those pieces for the bottom panel of the drawer. I've set the depth to cut at exactly 9 millimeters. I've already gone ahead and installed the same style bit that I used to make the dado in the drawer sides and fronts, except it's a 9 millimeter, not a 12 millimeter. Gone ahead and adjusted my guide stops to the center line that I created on the scrap piece of plywood earlier. Not only does this board have some important start and stop points on it for me, but it gives support to the router, the guide rail, as well as locking in my drawer sides and fronts. With my flag stop set, I can do my first dado, flip it over, do my other one, and then complete the same process with the rest of the drawer sides. The main reason I put the dado in to accept the drawer bottoms on all my drawer pieces before I do the joinery is because it gives me a good reference point on where to put the dominoes or the rabbets or the vertical dado. As you can see with this sample, all the dados need to be on the inside. And if we look where that rabbet is, the rabbet is opposite side of where that dado is. Next step in the process is to cut the rabbet. So after I created the dado, the only thing I need to change on the router is the guide stop. So I've done a course adjustment to move it over to create that rabbet, but now I'll fine tune it with this green dial to micro adjust it. With everything set, I can go ahead and cut 12 rabbets, 2 for each drawer front and back. After I get my first piece cut, I always like to try and do a dry fit, make sure everything lines up and fits correctly, and this looks good. Now I can flip it around, do the other end, and the other pieces will follow the same process. For the wider drawers, all I need to do is reset my flag stop, lock that into place, and cut the rabbets for those. So with all 3 drawers in dry fit, they all look good. I can go ahead and measure for the bottom panels of all the drawers. I'll do them the same way I did my large drawers. Go ahead and measure inside to inside dimension, both directions. And I know my dado, the depth of my dado, both directions. I can calculate that, add that to my dimension, give myself a little bit of wiggle room, 2 to 4 millimeters, then I can cut them to size. So 2 drawers all glued up, third one about ready to pull out of clamps. The next step in the process is to do a little bit of light sanding. The plywood itself comes pre-finished at about 120. So that's the grit of abrasive that I'll use on my sander. Now with everything sanded, I can go ahead and take my MFK 700 with a round over bit and round over this inside edge just to reduce any chipping or tear out. Whether I'm installing 5 drawers or one single drawer, the process is always the same. Build the drawer box, I install the drawer slides, and then I install the drawer front. With these 3 drawers being in the same location, I went ahead and I figured out the placement of the drawer slide, made a template, drilled some holes. Now I can just put this template in here, drill all the holes. I don't have to measure anything. On the larger drawers, I use soft close drawer slides. For these smaller drawers, they're going to be holding manuals, paperwork, lighter stuff like that, so I won't need that soft close feature. So I already have my drawer fronts sanded with a slight round over. I've gone ahead and also made another jig that matches what my hardware is. Put a center line on my drawer fronts. With all the holes for my hardware pre-drilled, all I need now is to be able to space the top of the drawer front down slightly. So I've got a gauge block, and I've made marks both left and right to get it centered up. Then I can just run my screws in and then attach it from the back side. So I've got the hardware put on the center drawer. It looks good. I can go ahead and knock out the small drawer and then the larger drawer. With the doors and drawers complete, I'm really excited about all the storage space I've gained. Now I can focus on bringing in those accessories and consumables and have a place to put them. For now, I'm going to step away from shop improvements and focus on projects. If you have any projects you'd like to see me build, let me know in the comments. Thanks for watching this build series. I hope you learned a few things along the way. Go spend some time in your shop. I've got some organizing to do.